Assalamu alaikum everyone. I am Mohammad Qasim from class 9th representing Future X Paripura. I study in Tenel Visco School and today I am going to be a one-day teacher. And my topic is going to be motion and rest, which is indeed a topic of physics. So let us start now. Before that, I must ask you a question. If you're moving in a car or you're driving it and somebody outside of the vehicle sees you, he will think that you're in motion, but to you, you're in rest. So from this, we can conclude that motion and rest depend only on reference points. Now, let's move on to our first subtopic, motion. So let us first know what is motion. If I consider this to be point A and this to be point B, and then I move from point A to point B, how do you know that I was in motion? You can only see that by taking the points as a reference. First I was at point B, then I changed my position to point B. This means that motion can be defined as the change in position with reference to a stationary object. Taken as reference point. We can only define motion when we know about the position of an object. If we do not know the position, we will not be able to tell where the person started his motion and where he ended it. Suppose you're in a dark abyss and you don't know where you are. Even if you move, somebody else would not know it. Why? Because he has no reference point he has no stationary object to take as a reference point. Now, a second definition is rest. So, we said that this point is point A. So, when I stand here you would not be able to know that I was in motion. Why? Because I was only at point A and I did not change my position, which means that rest is not changing your position. Not changing position. Rest is just staying still and not doing anything. Even if you're at a point and you don't change your position from that point, it can be said at rest. So, this concludes our two definitions, motion and rest. Now, let's move on to another definition. Uniform and non-uniform motion. Consider a car moving from point A to point B, and he first covers 2 meters in 4 seconds. Then he covers 5 meters in 7 seconds. Then 8 meters in 9 seconds. His speed may change. Now, we shall make the time intervals equal. Consider this 2 seconds, then this 2 seconds, then this 2 seconds. We can see that the object moves unequal amount of distances in equal intervals of time. If we change the time intervals, we may not be able to know if the motion is uniform or not. So that's why we keep the time intervals same. Now you can see he first moved 2 meters in 2 seconds, then 5 meters in 2 seconds, then 8 meters in 2 seconds. This means that he has a non-uniform motion. He is not covering equal distances in equal intervals of time. Rather, he is covering unequal distances in unequal intervals of time. Why we keep these time intervals equal? To know the motion of the object. Now consider this. The object moves 7 meters in first 2 seconds, then 7 meters in first, then 7 meters in second 2 seconds, then 7 meters in third 2 seconds. This means that he covered equal distances in equal intervals of time. His rate of changing position did not change. This means that his motion is uniform as he is covering equal distances in equal intervals of time. First he covered 7 meters in 2 seconds, then 7 meters in 2 seconds, and then another 7 meters in 2 seconds. Now we can define uniform motion as a body is said to be in uniform motion if it changes its position in equal distances, if it changes its position uniformly. That means he covers equal distances in equal intervals of time, not unequal distances. And then we can define non-uniform motion as a body is said to be non-uniform motion if it does not cover equal distances in equal intervals of time. That means his rate of change of position is not uniform. This concludes the 2 subtopics. Now let's move on to another. Distance and displacement. You all may know what this is. This is a right angle triangle. Suppose your house is at here, point A, a shop is at point B, and your friend's house is at point C. You first move from point A to point B to grab some milk and then go to point C to meet your friend. This is the actual length of the path covered by you. But consider this, you don't go to the shopkeeper, you just move to your friend's house in a straight line. This is the shortest distance between initial point and final point. This actual length of the path covered by you is called distance, and it is a scalar quantity. What do we mean by scalar quantities? A quantity which has only magnitude, no direction. And vector quantities are those quantities which have magnitude as well as direction. Example of scalar quantity is distance, time, and examples of vector quantity are displacement and other quantities also. So you may say, why distance is a scalar quantity, why isn't a vector quantity? When displacement, the shortest line, the shortest distance or the straight line from initial point to final point is a vector quantity. This is actually because when you see he went from point A to point C, he was actually moving in south direction, and then he moved to east direction. Now it's up to our reference, not his. From his perspective, he must be going north or east. We don't know that. From our perspective, he's moving south, then he moved east. This means that his direction changed. The direction in which he was moving changed. So that's why distance is a scalar quantity. Now consider this, displacement. He just moved in the same direction from initial point to final point, which to our reference is actually southeast. It had only one direction, it did not move in any other direction. That's why displacement, the shortest distance or a straight line from initial point to final point, is a vector quantity. Now we can define distance as the actual length of the path covered by a body moving from initial point to final point. And then we can define displacement as the shortest distance or a straight line from initial point to final point. This concludes the 2 subtopics. Let's move on to another subtopic, that is speed and velocity. Now, if a car is moving on the road, how would you know that car is fast or not? You will obviously say that car is going fast, so that its speed must be fast, or the car is going slow, so the car must be slow. But what if you want to express it? You can only express the rate of change of a position of an object by speed. V speed is denoted by V, distance is denoted by S, and time is denoted by T. V is equal to S by T. This means that speed is equal to distance divided by time taken. Speed is a vector quantity, as distance is also a vector quantity and time is also a vector quantity. Anything derived from a certain type of quantity is that type of quantity, which means that if speed is derived from a scalar quantity, it must be scalar quantity. It cannot be vector quantity. Now let us define speed. Speed is the distance covered by an object per time taken or per unit time. Why we consider it as speed divided by time? Because it is a rate, and rates are always denoted as percentages, or what we call as denominators and numerators. These are rates. So rates are always expressed using these. That's why speed is also expressed as distance covered by time taken. Now let us consider another thing, velocity. Now, if the car is here, pardon my drawing, it's not that good, and it moves upwards in a linear, rectilinear motion, you see that it is only traveling in one direction and it is not changing its direction. So it's called velocity. It is the speed, it is a distance covered in a given direction, or displacement per unit time. Here is velocity. It is denoted by a vector. Why? Because it is a vector quantity. V vector is equal to S vector by T. So we can now define velocity as the distance covered in a given direction, or displacement over unit time or time taken. Speed, now let us recapitulate what we said. Speed is a scalar quantity, velocity is a vector quantity. Why? Because speed has no direction and velocity has a direction, as it is derived from a vector quantity, displacement. That is all for today. Thank you, and see you next time.